Welcome to this lesson on indirect measurement. Today we're going to talk about how to use indirect measurement and what indirect measurement is. So let's think about if we were trying to measure the height of the real school and all the things that we would need in order to be able to do so. We'd need a large ladder to be able to get from the ground to the top of the building, and we'd need a long enough ruler or tape measure to drop from the top of the building to the bottom of the building. In this case, that's going to be very difficult to do, and it's going to require a lot of different people. So this is where we use something called indirect measurement. An indirect measurement measures the distances that are difficult to measure directly. So you have the word indirect, which tells you that it's not happening. So if we say it's happening directly to something, it's happening right then and there, it's happening to that piece. But if we're doing indirect, we're not necessarily measuring this, we're measuring something else to help us measure the building. Right. So when we're using indirect measurement, you have to think about objects that are outdoors. We're going to start with that. And we can use their shadows to help us find the height. And how this works is that, let's say we use a person, so the triangle is formed by a person and their shadow, and then the imaginary line from the top of the head to the top of the head of the shadow. Now we know that the person makes a right angle with the ground, and then whatever we're measuring, so in this case this very large snowman, also makes a right angle with the ground. Now granted, here it obviously curves off, but we're talking about from the middle of that snowman. Right? Now, because both of them have those right angles based on all the characteristics of triangles, we know that their angles have to be the same. And right now, I'm not just asking that you trust that that's true, because we're focusing on indirect measurement and not proving why these two are similar triangles. You also know about similar figures, so we're going to use similar figures within indirect measurement to help us out. So with this person, so if I'm this guy, I know that I'm 6 feet tall, and then I know that my shadow is 12 feet, or I can measure and find that my shadow is 12 feet. And then I also know I can't measure from the top to the bottom of the snowman because it is too large. Comparatively, look at where the man ends and then where the snowman ends, so you know it's much taller than 6 feet tall. However, you can measure from the middle of the snowman to the tip of his shadow. So if we do that and we get all these measurements, so we know he's 6 foot and we know his shadow is 12 foot, and we know that the snowman's shadow is 228 feet, and we know that these triangles are similar, we can look for corresponding sides. So we have the 6 feet and the h, because those are both the height. And then we also have 12 feet, which is the shadow, and 228 feet, which is the shadow. So what I can do is I can take and I can create a proportion and say that the man is 6 feet to his shadow, which is 12 feet. And I know that that has to be proportional to the height of the snowman and his shadow of 228 feet. From here, we know exactly how to solve. We know we use cross multiplication, so I get 6 times 228 is equal to 12 times h. So I can go off to the side and do 228 times 6. 8 times 6 is 48, carry the 4. 2 times 6 is 12, plus 4 is 16, carry the 1. 2 times 6 is 12, plus 1 is 13. And then, as always, we're able to use our calculator to double check. 228 times 6. All right, so we get 1,368. Perfect. So I get 1,368 is equal to 12 times h. I'm going to divide both sides by 12. Okay, and just to continue practicing and working on my skills here, so I have 12 goes into 13 once, I subtract and I get 1 and I bring down the 6. 12 goes into 16 once, minus 12 is 4, bring down the 8. 12 goes into 48 4 times, and I know that that's going to end up giving me 0, so I know that 48 is equal to h. So in this case, I know that this snowman is 48 feet tall. And again, we used indirect measurement. We measured the shadows and we measured the man so we could indirectly, so if we directly measured it, we would have taken a tape measure and a ladder and gone from the top of the snowman to the bottom. But in this case, we had to measure other things and use proportions to help us find the height of that snowman. Okay, and looking at this, does 48 feet make sense? Well, it makes sense to me because if you look, his arms are made out of actual trees. So he's got to actually be pretty tall and pretty strong to hold on to those. Not to mention he's significantly taller than the man. All right, so now let's go ahead and use this method without a picture, just looking at the information we're given. So you're outside and you want to find the measure of a building, find the height of a building, and you find a stick that's 3 meters, and its shadow is 1.5 meters, and then you know the building's shadow is 8 meters. So again, you can find corresponding parts just by saying, okay, shadow and shadow. So here I have shadow and shadow, and then I have the height, and then I want to find the height of a building. So in that case, that's what I'm looking for. So again, I have 3 meters, and actually instead of just going off of this, the next piece that we can actually do is we can actually make a sketch. So we can go and we can sketch our 3 meter stick that has the 1.5 meter shadow. And then we can sketch the building that has a height that's unknown and an 8 meter shadow. Now, these don't have to be perfect or to scale. The goal is just to help us out, and again, if we're struggling, to help us find those corresponding sides. So it's easier to see that these are corresponding and that the shadows, which should be on the ground because that's where shadows are corresponding. And then again, the setup is the same. So we have 3 and H, and those have to be proportional with the shadow and the other shadow. And now I know I use cross multiplication. I get 3 times 8 is equal to 1.5 H. So I get 24 is equal to 1.5 times H. Divide by 1.5, divide by 1.5. And just to save us some time here, 24 divided by 1.5, we get 16. So then H equals 16. So my sentence then would be the height of the building is 16 meters. All right, moving right along. So now we have a problem. If it's shadow, we don't have the ability to work with shadows. So this is where a mirror comes in handy, because you know I often believe that people just carry mirrors around, but this is what we use. So if you place a mirror on the ground, any light that reflects off of a mirror, so whatever angle it hits the mirror at, it comes off or reflects at that same angle. So because of the fact that you make that right angle with the ground, so we talked about right here, you make that right angle with the ground, and then in this case we're working with the stoplight, that makes a right angle with the ground as well. And then you know these angles have to be the same because light reflects off a mirror at the same angle that it hits it. So these angles are the same, so you know these are similar triangles. Right? Again, little confusing, but I'm trusting that you understand and know that this is true and that it is the reason that it all works. So now we have an instance where we're using the mirror, but the whole process is exactly the same. So in this case, we are going to look at this information where we have the height from the ground to Mike's eyes is 150 centimeters. And the distance to the middle of the mirror to Mike's feet is 100 centimeters. So that's different. The distance from the middle of the mirror to a point directly below the traffic light is 450 centimeters. Okay, so in this case, we're looking at this picture, and I'm actually going to grab this picture and copy and paste it so we can see what's going on here. So what this is saying is, and you could even, again, sketch this, that right here is 100 centimeters, and that here is 150 centimeters, and that this is 450 centimeters, and it's asking you to find the height of the traffic light. So again, you're trying to find this piece. So what is the height? All right, so again, we put our corresponding pieces together. So in this case, my reds were corresponding. So I have Mike, who is 150 centimeters, who also has a length of 100 centimeters between himself and the mirror, and that is set up proportional to the height of the traffic light, which we don't know, but that is 450 centimeters away from the mirror. Now in this case, we didn't measure to here because we want the height of the traffic light, not the pole. So you have to make a straight line down from where the traffic light is and then measure over. So again, is this going to be an exact measurement? No, but it's going to give us a pretty good idea of what the measurement is. And then again, we use our cross multiplication. So 150 times 450 equals 100 times x. 150 times 450 is 67,500 is equal to 100 times x. And then I know I divide both sides by 100. And then here my zeros cancel out. So this is 675 is equal to x. And x in this case is the height of my traffic light. So my sentence would be, the traffic light is 675 centimeters tall. All right, so we've gone through quite a bit of examples here. So you have 3 problems to try on your own. 1 gives you a picture, 1 and then 2 do not. 1 is just saying that you're using the mirror method, which we talked about. You're doing the exact same math. It's just the idea is a little bit different. So we're really focusing on making sure we can find our corresponding parts from word problems and then use that indirect measurement method to find the missing measurements. All right, so as always, I want you to try these problems on your own. If you have any questions, please be sure to email me or write them down so we can go over them in class.